Okay, this is for the advanced students, the ones who are taking grade 12 trig and really care about it. So let's draw a circle, a big one, on an ASTC graph. Let's call it a radius of 1. Meaning, if this is 0, 0, this, if the radius is 1, is 1, 0. This is 0, 1 at the top. This, on the left, is negative 1, 0. This, at the bottom, is 0, negative 1. We call this a unit circle because it has a radius of one single unit. Let's mark 0 and 180 for fun. 0 is also 360. Okay, so I'm going to make a triangle hugging the x-axis, making 90 degrees, our bow tie. And then I'm going to take this right angle triangle and draw it off to the left. So we have a hypotenuse of 1. And the opposite is just the y value. So in the diagram off to the left, I'm going to say y. In the diagram off to the right, I'm going to say opposite. Okay. Well, the adjacent is x. In the diagram off to the left in blue, and in the diagram off to the right in blue again, x. Now, interesting, okay. So we got our triangle in the graph. We've got our triangle off to the right. Oh, excuse me. Erase x and say adjacent ADJ. We know the adjacent is x. I wrote it again. Whatever. We know the opposite is y from the diagram that we've been talking about. The y value and the x value of the diagram. Let's go through a little bit of theory. So in the notes, I got the definitions at the top. I boxed them. So those are the answers. We're going to put the theory to get there. Sine theta is equal to opposite over hypotenuse. If the opposite is the y value, well then sine theta is equal to y over the hypotenuse. And what's the hypotenuse? 1. You don't care about ones. Sine theta is the y value of the point on the unit circle. I'm going to put the point in big blue. That point has a y value of sine theta. And they did a whole bunch of calculus to figure out this, and it just happens that we can use SOHCAHTOA. It's just a relation that works by similar triangles or whatever. Sine theta is equal to y value of the unit circle. That is the definition of sine theta. We've been faking it all along, SOHCAHTOA. Now, we're going to keep using SOHCAHTOA. We're going to use our new definition of sine theta, the y value of the unit circle. So what's cos? Well, cos theta is equal to adjacent ADJ over the hypotenuse HYP. So cos theta equal to, well, what's the adjacent? Well, above, it's the x value. So it's x over, and the hypotenuse is 1, so it's x over 1, so get rid of it. So it's cos theta is equal to the x value of the unit circle. So back up to big red, that point, that blue point, is x comma y, and we just learned that the x is cos theta, and the y is sine theta, so comma sine theta. Our new definition of sine and cos, the x and y value of the unit circle. Turns out tan theta is again TOA, opposite over adjacent. Well, tan theta, the opposite is the y value, and the adjacent is the x value. Tan theta is just the slope of the line. Rise over run. And then there's a whole bunch of me substituting in for things. Let's do a couple. So let's take the sine of 90 degrees. Well, 90 degrees is straight up. The point at the top has a point of 0, 1. We know sine is the y value, so it's 1. Circle your answer, check your answer on the calculator. Let's do the cosine of 180. Well, 180 is over here, and cosine from above is the x value, and the x value of the point above in the graph is negative 1. Check it on the calculator. Check mark, check mark. And there's every single one of those examples. Like, for example, tan of 90. Well, that's straight up, and tan, as we just learned from above, is the y value over the x value. And in the graph from above, straight up, the y value is 1 over an x value of 0. Tan theta, tan 90, is undefined, UND. Circle your answer. Check it on the calculator. Tan 90, undefined. And we're going to use this unit circle, and we're going to use these units of sine and cosine to draw a nice little sine graph, which is perfectly inside a box. That's 2 by 4. And a cosine graph, which is perfectly inside a box. That's 2 by 4. Using these definitions, sine theta is the y value, cos theta is the x value, to draw these graphs. So now we're going to draw these graphs.